name is Filza Zafarina. I will present about pancreatic cancer classification using logistic regression and random forest by Zuherman Rustam, Filza Zafarina, Glory Stefani Saragi, and Sri Hartini. First of all, I would like to say thank you to Universitas Indonesia who supported this research and give me the opportunity to join conference on Internet of Things and Embedded Intelligence 2020. This is our outline for presentation. One of the main diseases that causes death in the world is cancer. This disease can attack all parts of the body. One of the main causes of cancer-related death worldwide is pancreatic cancer. In the early stage, the disease has no showing or symptoms. The most symptoms occur when the disease is in the final stage. Pancreatic cancer is cancer that starts in the pancreas. The most common type of pancreatic cancer is pancreatic adenocarcinoma. Location of the pancreatic organs behind the stomach. The pancreas is about 6 inches long and less than 2 inches wide in adults. There are various treatments for pancreatic cancer, such as surgery, chemotherapy, radiation therapy, or combination of these. The method of treatment is chosen based on the extent of cancer. Information technology has an important role in the field of medicine. Cancer is a disease that can be detected by technology machine learning. Big data is very useful in the medical field. It can be seen from the development of data mining in medical science is increasing rapidly. This increasing can be seen from the high prediction results can reduce treatment costs, increase the chance of recovery of patients, and decisions to save life. Classification is a way to identify groups of categories to be part of observations. One general classification is the continued value of the predictive attribute. Pancreatic cancer dataset was obtained from Al-Islam Hospital, Bandung, Indonesia. This dataset consists of 79 non-cancer and 124 cancer samples with numerical characteristics described by 6 attributes as shown in Table 1. There are age, the number of aged patients who are in check, CI99, the number of cancer antigen unit per milliliter of blood, hemoglobin, the number of hemoglobin gram per deciliter of blood, leukocyte, the number of leukocyte cell per UL of blood, hematocrit or the volume percentage of red blood cells, thrombosis, the number of thrombosis cells per UL of blood. This research uses logistic regression and random forest for classification. These methods are evaluated by threefold cross-validation, 45 random stage, and later compared. Table sample of dataset shown in Table 2. Sample of dataset from Al-Islam Hospital, Bandung, Indonesia. In some cases, the natural complement of ordinary linear is logistic regression. This happens when each target variable is categorized. Variable y is variable target and dependent with two classes, and variable x is variable predictor and independent. Let gx equals prx equals x equal 1 minus prx equal x. The logistic regression model has a linear form for logit which probably as follows. The form of linear approximation and probability logarithm is derived from logit. The rate of increase or decrease of the shape gx curve is denoted by the parameter beta. Random forest is method developed by Bremen in 2001. Random forest works when it reaches maximum accuracy. A decision tree can be used to avoid overfitting data. The estimation process previously carried out by decision tree and CART was enhanced by Bremen, which was started by randomly selecting variables from several independent variables. The decision tree or CART method is a tree that grows without pruning. These trees will be selected with the highest accuracy. The procedure of random forest depends on the number of classifications. Confusion matrix is balanced in the precision and sensitivity that distinguish correct label classification in the different classes. In confusion matrix, there are true positive, false positive, true negative, and false negative. True positive is number of samples having pancreatic cancer diagnosis. False positive is sum of healthy people that were incorrectly identified to have pancreatic cancer. True negative is number of healthy people correctly spotted. And false negative, number of samples with pancreatic cancer that were incorrectly classified as healthy. Table 3 explains about confusion matrix. From table 3, it can be built the formula for accuracy, precision, recall or sensitivity, and F1 score that are seen in the equation below. This research using Jupyter Notebook as software for running the program of logistic regression and random forest in processing pancreatic cancer classification problem. Testing the accuracy, precision, recall, and F1 score in this type of classification are by changing the amount of data training. Result of accuracy, precision, recall, and F1 score, which are given by logistic regression and random forest classifier method, are shown in Table 4 and Table 5. Table 4 is the result of pancreatic cancer classification using logistic regression. Based on Table 4, it is shown that number of data training is affected by the value of accuracy, precision, recall, and F1 score. In this research, the highest accuracy value was recorded when the data training is 30% with 96.48%, while the lowest accuracy value was recorded when the data training is 70% with 91.49%. In precision, 70% and 90% of data training reach a maximum value that is 1 100%. For the recall of the Hedges value is 97.70% for 30% of data training, and the last for F1 score 30% of data training reach the Hedges value that is 96.29%. Table 5. The result of pancreatic cancer classification using random forest. Based on Table 5, it is shown that the number of data training is affected by the value accuracy, precision, recall, and F1 score. In this research, the highest accuracy value was recorded when the data training is 20% with 99.38%, while the lowest accuracy value was recorded when the data training is 90% with 89.68%. In precision, 10%, 20%, and 30% of data training reach the maximum value that is 100%. For recall, the recall of Hedges value is 99.10% for 10 of data training. The last for F1 score, 20% of data training reach a maximum value is 100%. Conclusion. After classifying pancreatic cancer with logistic regression and random forest methods, it got several results of accuracy, precision, recall, and F1 score. By comparing the values that are given from those methods, it is possible to conclude that random forest generates a better result than logistic regression. The result of two methods random forest give the highest accuracy rate when the data training is 20% with 90.38%, while logistic regression reached 96.48% when the data training is 30%. Because of good result, random forest is suggested to help the medical staff to predict or classify a disease, especially for dataset that is similar to this research. Thank you. This is our reference. Thank you.